Good morning, students. In this video, let us see the systems classification, static and dynamic systems. So the classification of the system here, it is static and dynamic systems. Let us define these two systems. Here the static system is also called as memoryless system, whereas dynamic system is also called as system with memory. First, if you see the definition, we can easily interpret these two expressions. Fine. Static system means if a system input x of t, output y of t considered. Here x of t is present input, y of t is present output. Fine. The static system means present output should depend only on the present input. What is the definition of static system? Means present output depends on only present input, no other values of input or outputs. Fine. Present output depend on only present input. There should not be any past values of input or output, anything. Whereas the dynamic system means present output depends on present input and past input and slash r outputs. It indicates present input and past input and slash r outputs. That means any one past value should be there. So the present output should depend upon any one past value, whether input or output. Present input is there. Here also present input is there. Here there is no past values. Here past value should be there. That is the only difference. Whether past value is there or not, we have to verify. Or simply we can remember like this. Static system means only present values are there. In all other cases, dynamic system. Fine. Static system means if the present output depends only on the present input, it is a static system. In all other cases, it should be a dynamic system. It should have some memory to store the past values. That's why it is also called as memory system or system with memory. This is memoryless. It cannot store any past values of inputs or outputs. Like that we can determine or we can differentiate these two classifications, static and dynamic. Let us consider some examples here. And I am recalling you, I have already discussed in causal and non-causal systems what is the terminology we are following for present, past, future values of signals. Anyhow, I am giving directly here. If x of t signal is considered as present, then we should consider x of t minus some constant as past with respect to this. X of t plus 2 should be considered as future. This is what the terminology. I have clearly explained there how to consider the terminology. Anyhow, here let us remember what is the present, what is the past, what is the future value based on these notations. Now I am considering examples. First, y of t is equal to 2 into x of t plus 3. Second, y of t is equal to modulus of x of t plus 3. Third one, y of t is log of x of t plus 5. And fourth one, y of t is equal to x of t plus 1 by x of t minus 3. Next, 5. Y of t is equal to x of 3t. Fine. These are the systems. Let us classify whether those are static systems or dynamic systems. Fine. Y of t is 2 x of t plus 3. Here y of t present signal, x of t also present signal, only present values. That means the system is static system. Similarly here, x of t present, y of t present, x of t also present. Both signals are present. Like this. Only present. Means it is also static system. And this one, here modulus is there, here 2 is there, irrespective of other quantities. Only x of t consider. And follow this terminology. Y of t present output, x of t present input, irrespective of other quantities, whether log, whether magnitude, or any square root, whatever it may be. It should not be considered. Only input expression we need to consider. This is present, both are present, that means a static system. And here, y of t present output, x of t present input, but 1 by x of t minus 3 minus quantity indicates past value. So that there is some past value. Here the system output depends upon past value of the input. The system needs some memory to store the past value. Anyhow, the system is not a static system. It is a dynamic system. Similarly, y of t is equal to x of 3t. Observe here, y of 2 I want. That means t is equal to 2 I have considered. Then y of 2 is equal to x of 3 into 2, 6. That means 2, 6. Here output present, input is here future value. So the present output not only depending upon any present values, it also depending upon other quantities. Here future value is there. That means the system is not a static system. It is a dynamic system we have to consider. Of course, the same classification, same equations we can consider for causal, non-causal systems also. There we got it, non-causal system. Fine. Thank you. Like that, you can verify.